All right, so I'm Ben Tershak, research biologist with Michigan DNR. I am one of two co-chairs on the Salmonid working group. With my other co-chair is Ben Dickinson with Indiana DNR. There's a lot of folks on the Salmonid working group that have contributed data to this presentation, pretty well represented across the states and federal agencies working on Lake Michigan, as well as some university partners. So big thanks to those folks that contributed data to help support this effort. One of the major tasks the Salmonid working group is given each year is to produce the annual predator-prey ratio, which is very simply understood as the relative abundance of the primary predator species in Lake Michigan in terms of preferred among recreational anglers, that is, and dominant consumer in the lake, to its preferred prey source, which are alewives. So that's Chinook salmon to alewife, and this ratio gives us some idea of relative prey abundance for that predator. And so the top panel that you're looking at here is the biomass of age 1 and older Chinook salmon in Lake Michigan through time. The second panel is the biomass of age 1 and older alewives in Lake Michigan through time. And then that bottom panel is simply the ratio of those two. So higher values indicate that there's relatively fewer prey for the number of predators. Lower values indicate that there's more prey for the number of predators that are out there. Now, I should point out that both those two upper panels are estimates that are derived from catch-at-age models, some of which we don't have data yet for 2025. That's still being summarized and compiled. And so what you're looking at here is an update through 2024, which is the first time it's being presented at an Upper Lakes meeting, but it's obviously a bit out of date at this point. But what you could see is that Chinook salmon biomass had been, coming off of several years of increasing, values. The prey model or the alewife biomass has been declining correspondingly, and that's resulted in an increasing predator-prey ratio. So relatively fewer prey available for the number of predators. So in addition to the predator-prey ratio, there's a number of secondary indicators that we can actually take a look at 2025 values for. The first three of those indicators relate to Chinook salmon and salmonine predators in Lake Michigan. The latter three indicators are more related to alewives and are derived from that same catch-at-age model that's used for the predator-prey ratio. So I won't be able to provide updates on indicators 4 through 6, but we'll talk a little bit about that. So I'm going to start with our first indicator here, which is the weight of an age 3 female Chinook salmon returning to weirs and harbors. So this is simply an indicator of the size. How much weight were these fish able to put on in their 3 summers that they spent in the lake, or 4 summers they spent in the lake. So this comes from a number of different facilities around Lake Michigan. Wisconsin operates the Besadny Anadromous Fish Facility, or the BAFF facility there. They also have the Root River and Strawberry Creek weirs. In Michigan, we have the Little Manistee River, the Medusa Creek weir, and then also our Boardman River weir. And in Illinois, there's electrofishing surveys that happen in harbors to collect this information. And so through time, these colors represent the weight of age 3 females that are coming back to each of these locations. We generally see very similar patterns. In the period around 2020 and a few years after that, we saw some large departures from one another in that time series. But in generally, we've seen that these have reconverged in 2025, with maybe the exception of the Boardman River, which was a really small sample size in 2025. So in general, we've seen a declining trend. Looking at just a handful of index sites, you can see that maybe a little bit more clearly. But most of these sites have now declined below a weight of 15 pounds for that age 3 female. And that's sort of one of our state of the lake indicators or benchmarks. That 15 pounds is sort of the mark that we're looking for. When we fall below that, that's usually indicative of predator-prey balance that's lower than what we're looking for. So here again, looking at the weighted average of all these locations combined, this is coming off of a multi-year decline going back to about 2019. So and it's really the lowest value that we've seen since about 2015. So one other indicator I want to talk about here is the standard weight of a 35-inch Chinook salmon, very much in the same vein as the weight of an age 3. This is giving us some idea of growth in Lake Michigan, during the summer. So this is recreationally caught fish from July 1st to August 15th. And the standard weight is very simply understood as, by taking these length weight relationships on any given year. You trace a line up from 35 inches on the x-axis and draw it to that relationship and draw a line over to the y-axis. That's going to be that intercept is going to be our standard weight at 35 inches. And in general, in Lake Michigan, this population is pretty well mixed. So when you're getting these fish from the open water fishery, fish stocked in Wisconsin could be caught in Michigan waters and vice versa. And so generally we see very similar patterns across the jurisdictions, which are represented in the colors here. And here again, we're seeing a decline. This has been on a longer term declining trend since again around that 2020 kind of time frame, with occasional spikes. So here we can see. Let's see if I can point this out. There's a couple spikes here, but in general, we've been on a sort of slight declining trajectory over the last handful of years. These spikes correspond to recruitment events of alewives, I believe. So there was, alewife biomass has been declining, but occasionally there's a slightly above average year class that comes off. The Chinook salmon respond very quickly to those, and we see higher standard weights during the middle of the summer. So that 21 year class produced some larger fish in 2022. The 23 year class of alewives produced some larger fish in 2024. But in general, we're seeing a decline in the size of these fish. All right, so the second indicator is catch rate of Chinook salmon. So now we're not looking at size so much as numbers of fish that are showing up in our charter fishery. This is just charter reporting at this point. And so looking at the top panel here, we're looking at harvest in the upper panel across jurisdictions, effort in the middle panel, and then a catch rate. So simply dividing that top panel by the middle panel to get our catch rates. And what we're seeing is across Michigan and Wisconsin, even in Illinois and Indiana, which have a relatively small proportion of Lake Michigan, we're seeing increases in catch rate that have corresponded to increased harvest. Effort has been relatively constant through time across these jurisdictions, but this is really driven by increased harvest in the charter fishery. So if we take all these things together, we can see that there's been maybe an increase of 3 times or more in the catch rate in that bottom panel, looking across all jurisdictions combined. And then looking at effort, this is, I think, it's relatively stable through time. It's on a pretty truncated Y scale. And the dynamics that we see, I think, are actually driven more by economic factors than any kind of than anything else. So just for instance, the drop here corresponds to the 2008 sort of like economic downturn that we had again in 2020, and then there were sort of economic stimulus packages in 21. We see this bouncing around that I think corresponds pretty nicely to economic drivers, but really it's quite stable relative to harvest, and so the catch rate is driven by that increasing harvest in recent years. Third indicator is the composition of our angler harvested weight by species, and so this is looking at the entire Salmonid community in Lake Michigan and what anglers are harvesting within that community. And so first I'll show there's 5 panels here for each of the 5 primary salmonid species in Lake Michigan: brown trout, Chinook salmon, coho salmon, lake trout, and steelhead. I have it broken out by jurisdiction here. The main thing I want just highlight a couple things with respect to brown trout. The vast majority of harvest, and this is recreational harvest, including charter fishing and just sport anglers. Most of that harvest of brown trout is happening in Wisconsin waters. That dominates the brown trout portion of the fishery. In recent years, there's been a bit of an uptick, but it's at relatively low levels. Chinook salmon, we see Michigan and Wisconsin, they make up the vast majority of the area of Lake Michigan. And so we see catch rates or harvest in those locations increasing sort of at a similar trajectory, maybe a bit more harvest happening in Michigan than in Wisconsin, with Illinois and Indiana making up relatively less of that. Coho salmon, same thing. We see we see harvest bouncing around there. It's similar across jurisdictions, notably almost as high in Illinois as it is in Michigan and Wisconsin, which is interesting considering how small an area they represent in Lake Michigan. Lake trout, Michigan dominates lake trout harvest. That we've seen that declining in recent years, and steelhead has been low but relatively stable compared to some of the other salmonids over recent years. So if we take all that together to sort of look at these broader patterns, brown trout are way down from where they were during their highs in sort of the early 90s, maybe slightly increasing in recent years. Chinook salmon, as we saw with the charter fishery, has been increasing substantially. Note the Y scale is an order of magnitude different than these other species, and so small changes there would be reflected, in a much larger way on some of those other axes, but that they really dominate the fishery. Coho salmon, I think, are an interesting story here. We see that the long-term average isn't trending in any particular direction, but you see these spikes up and down each year. So if we were to look at these spikes, these usually correspond to year classes of alewives. And so these coho salmon spend 2 summers in the lake growing. They respond very quickly if there's synchronization with an alewife year class. So any kind of recruitment event for alewives that's synchronized with coho salmon seems to result in higher survival and correspondingly higher catch rates. So in 2010, we saw a big year class of alewives. In 2011, we saw a spike in catch rates of coho salmon. Same thing in 2012 with the 2013 spike. 2015 and 16 year classes of alewives showed up. We see another spike. And then 21 year class and 23 year classes each correspond to a year lagged response of that coho salmon community to that and increases in the catch. Lake trout, I think, as Laura pointed out, has been declining in recent years. That decline likely corresponds to the sort of reciprocal relationship between Chinook salmon and lake trout. So when anglers are able to catch their more preferred sort of silverfish species, they tend to target lake trout less. It could also be related, at least in part, to the reduced stocking in some of those southern management units. And so it's interesting, I think, to look at the reciprocal nature between these spikes in Chinook salmon in the corresponding declines in lake trout. There's quite a reciprocal catchability pattern that we observe in those two species. And then steelhead, as I said before, are at low levels relative to where they were in the 90s. But since about 2004, the long-term average has probably been not trending upward or downward in any in a strong way, at least. So taking all those things together, we can really see here that Chinook salmon, that sort of yellowish brown color, represents the vast majority of what's being caught, and that overall salmonid catch in 2025 is near the highest that it's been in recent years, with the exception maybe last year. This is about the highest that we've seen since 2012. So driven in large part by large catches of Chinook and coho salmon. And so this is just looking at that as in a proportional way. But Chinook and coho now make up about 80% of the overall catch in Lake Michigan in terms of weight of harvest. So, I mentioned the predator-prey ratio in the first slide, and that we don't have updates for 2025 yet. But as it turns out, and I think it makes a lot of sense here that these secondary indicators are well related to that predator-prey ratio. So those first indicators I mentioned, things like the weight of an age 3 female returning to weirs, the size of a 35-inch Chinook salmon, that standard weight. These size indicators are sort of inversely related to the predator-prey ratio. So as the predator-prey ratio increases, that's indicating that there's fewer prey relative to the number of predators, and so we'd expect size to go down. And so there's this inverse relationship. And if we look at that, we in fact see that, relating the predator-prey ratio to those indices, we see these negative relationships. Some of these R squares are pretty decent. They actually get much better when you smooth them over about a 3-year time period, because I think it's really predator-prey conditions over the summers of growing that are happening that give way to those standard weights. And so it's more than just what happened in the last year. And if you actually do that sort of 3-year moving average, some of these R squares will approach 0.9 in some cases. So pretty strong relationships. In this particular instance, I'm trying to use these to sort of estimate what I expect the predator-prey ratio to be. So I just used the 1 year, like in the terminal year, what are we going to have in terms of a predator-prey ratio. And this final panel here, this is catch rate. So as there's more and more predators out there, you'd expect there to be relatively fewer prey. So there's this nice direct relationship between the predator-prey ratio and the catch rates. So if I were to use those things, look at those through time, each of these lines would be that secondary indicator and what its prediction of the predator-prey ratio would have been. The black line is the actual predator-prey ratio from our modeling efforts. And then in 2025, they're all sort of coming out, up here. So another substantial increase in a predator-prey ratio that has been trending up for about the last 5 years. So I think we can expect that predator-prey conditions are going to continue to sort of trend toward fewer prey relative to the numbers of predators in Lake Michigan for the 2025 model updates. These last three indicators, as I mentioned before, are all related to are all outputs from the prey model, which we don't have run yet. So we have lake-wide biomass of alewives. That is the denominator of the predator-prey ratio. The annual alewife predation mortality rate, and the age structure of the alewife population. And so the last two indicators in particular, if you think about the age structure of the alewife population, we're often thinking about things like age truncation of that population. So the number of for the number of ages that are present in the lake for alewives, typically things are age 7 or less. The vast majority of what we're seeing in the age compositions are these fish less than age 3 typically, and so there's this truncation or skewing of the population to these younger ages. And I think that's largely driven by high mortality rates that simply aren't allowing the fish to reach those older ages. And so these last two indicators are sort of intricately linked with one another, and they certainly affect the fourth indicator, which is the biomass of alewives. And I can show that here in the next slide. So in the upper panel here, we're looking at alewife biomass through time from our model. In the next panel down, we're looking at estimated predation mortality rates. And I think I just draw your attention to a couple time periods here. These are time periods where we've seen consistent increases in the alewife biomass in Lake Michigan, or estimates of alewife biomass in Lake Michigan. And those have corresponded to periods where this estimated predation mortality rate is less than about 0.3. And really, there's only two time periods in the entire time series, going back to the early 70s, that we've seen these consistent increases. In both cases, they corresponded to these really low mortality rates. Contrast that to this period from the early 2000s through about 2015, where we see this really long-term consistent decline in alewife biomass, and that corresponded to a predation mortality rate that was greater than about 0.5. And so I don't know if it's possible to achieve stable conditions, but I think we can reasonably ascertain from this that if we wanted to increase alewife biomass in Lake Michigan, we're really striving for a predation mortality rate that would be less than 0.3. And if we want to drive alewife biomass downward, in this area above 0.5 would be the right place to be. So looking at this, as a whole, again, here's Chinook salmon biomass at the top. It's been increasing for the last several years. Alewife biomass has been going down with a corresponding increase in this predator-prey ratio, and that we now see that predation mortality rates are above that 0.5 mark and are likely to be resulting in conditions that are going to continue to drive alewife biomass down moving forward. So with that, I think that's about all I have. I have a link here to our the annual report that we produce each year. That'll be updated as we get models run and updated in the coming year. But with that, I think I maybe have a couple minutes for questions.